Throughout this series, we've explored how volcanic eruptions can reshape the land, alter the atmosphere, and change human history. But what happens when an eruption doesn't just impact a region, but the entire planet? Welcome to the terrifying world of supervolcanoes. In this segment of Infinity Beyond, we investigate what defines a supervolcano, why Yellowstone has captured global attention, and whether humanity is truly prepared for an eruption that could darken skies and disrupt life for years. First, let's define the term. A supervolcano is not just a big volcano. It's a volcanic system capable of ejecting more than 1,000 cubic kilometers of material in a single eruption. That's enough to bury entire continents under ash and alter the global climate for decades. There are only a handful of supervolcanoes on Earth. These include Yellowstone Caldera, USA, Lake Toba, Indonesia, Campi Flegrei, Italy, Taupo Volcanic Zone, New Zealand. Each of these sites is massive in scale, often covering hundreds of square kilometers. And all of them are being closely monitored by scientists. Among them, Yellowstone is perhaps the most infamous. Located in Wyoming, Yellowstone National Park sits atop a massive volcanic system that has erupted 3 times in the last 2.1 million years. The most recent eruption occurred around 640,000 years ago, forming the Yellowstone caldera, a depression so large most visitors don't even realize they're standing inside a volcano. Since then, the system has remained active, with earthquakes, geysers, and ground uplift as constant reminders of the power beneath. But here's the question that keeps researchers awake at night. Are we overdue for another super eruption? Statistically, it's complicated. While some have claimed that Yellowstone erupts every 600,000 to 700,000 years, scientists caution against using averages to predict rare geological events. Nature doesn't follow a schedule. That said, the potential consequences of an eruption are staggering. If Yellowstone were to erupt at full force, it could eject thousands of cubic kilometers of ash into the sky, create a volcanic winter, blocking sunlight and reducing global temperatures, collapse agriculture in major food-producing regions, contaminate water sources and cause mass displacement, severely disrupt air travel and global trade. Some models even suggest the eruption could lower global temperatures by 3 to 5 degrees Celsius, enough to trigger famine and economic collapse on a worldwide scale. But is such a scenario likely? According to the U.S. Geological Survey, USGS, there's no evidence that an eruption is imminent. Yellowstone is being watched by an array of sensors, from GPS stations to seismic monitors to satellite imagery. Any significant changes in magma pressure, gas emissions, or tremor activity would trigger alerts. As of now, Yellowstone shows no signs of unusual behavior. However, scientists continue to study past eruptions, magma chambers, and geological history to understand how supervolcanoes operate and how we might get ahead of one. Interestingly, recent research suggests that supervolcanoes might not erupt with a slow buildup like smaller volcanoes. Instead, they may remain dormant for thousands of years and then erupt suddenly with minimal warning, a geological snap. This possibility has sparked global concern and global cooperation. International science teams are now analyzing other supervolcanoes, like Campi Flegrei near Naples, Italy. This volcanic region has shown signs of ground uplift and increasing gas emissions, prompting Italian authorities to begin public education campaigns and emergency planning drills. Similarly, Lake Toba in Indonesia, the site of the largest known eruption in the last 74,000 years, is being re-examined for signs of pressure buildup and seismic unrest. But preparing for a supervolcano eruption isn't just about local response. It's about global coordination. If one of these giants erupted, the world would need to act fast, sharing resources, managing food supply chains, coordinating climate responses, and protecting vulnerable populations. It would be a test of civilization. That's why projects like GVM, Global Volcano Model, and SABRE, Stratospheric Aerosol and Gas Experiment, are so vital. They bring together volcanologists, climatologists, and disaster experts to simulate outcomes, identify hotspots, and develop early warning protocols. Some scientists are even exploring the idea of actively cooling supervolcanoes, injecting water into magma chambers to reduce pressure. While still theoretical and highly risky, these proposals underscore just how seriously the threat is taken. Because unlike earthquakes or tsunamis, a supervolcano doesn't just strike one region, it strikes the world. At Infinity Beyond, we ask the hard questions, not to spark fear, but to spark preparedness. What would it take to survive a supervolcano? How would we adapt? And could this be the disaster that finally unites humanity in global cooperation? In Segment 9, we'll explore how volcanoes on other planets, like Mars, Venus, and even Jupiter's moon Io, offer insights into our own planet's violent history, and whether volcanic activity shapes habitability across the solar system. The story isn't over. It's only growing deeper.